In this case, still two premises. We're looking for kind of more, it's a little more complicated. I guess it really is. If P, then if Q, then R. Not R, therefore not P or not Q. If you take a look at your sheet, exportation has a rule that looks just like this. Rather, half of the rule looks exactly like that. So what we can do is we can use these rules of replacement, in this case exportation, from line 1 to derive what? If you look at the sheet, you'll see this statement here kind of on the left-hand side. And so we can replace it with what's on the right-hand side. If P, then if Q, then R. Well, if you have P and Q, then you have R, right? The answer is yes, that is right. Well, now, here's R as the consequent of our if-then statement. And in a previous given premise, we know that R is false. And so what do we use when we have an if-then statement where the consequent is in another line shown to be false? That's modus tollens, 7.1 all the way. And modus tollens says if you don't have the second part, you don't have the first part either. So we can conclude from this that the first part, P and Q, is false. Because we didn't have the necessary condition, we can't have the sufficient condition. Or if you'd rather, because we didn't have the consequent, we don't have the antecedent either. So this is lines 2 and 3. Modus tollens. You with me so far? Hope so. If you don't have both P and Q, if the one thing you know you don't have is P at the same time as Q, then either you don't have the P or you don't have the Q. And what rule is it that allows us to do this? Your friend and mine, De Morgan's. This is the tricky one. Remember, I told you De Morgan's is one of those ones that you're going to use, frankly, very, very frequently, because it allows you to change, in this case, from an and to an or. Okay? So we know that we either don't have P or we don't have Q. Luckily for us, that's the conclusion. So this one's done too. What we had to do, once we got this, by setting up modus tollens, then we had to rename it. We had to say it in a different way in order for it to match the conclusion. These mean the same thing. And if you don't believe me, draw the truth tables. You'll find out they're true under the same conditions, false under the same conditions. They are truth functionally equivalent. It's a fair move. Plus we have the rule, of course. But we needed this statement to look like the conclusion. And De Morgan's allowed us to do that. It's almost like magic, isn't it?